Your brain actively turns off its own internal timekeeper and silences your inner critic the exact moment you enter deep concentration, creating a physical, neurological illusion where 4 full hours collapse into 4 fleeting minutes. You are not merely ignoring the clock on the wall. Your prefrontal cortex literally revokes access to your subjective sense of self and temporal awareness in an evolutionary energy trade-off that trades objective reality for peak biological performance. You are about to uncover transient hypofrontality and the systematic suppression of the default mode network, the precise neural shutdown sequence that systematically dissolves your perception of passing time. Think back to the last time you were completely immersed in a project. Maybe you were writing code, painting a canvas, mastering a complex musical passage, or analyzing an intricate puzzle at work. You sat down at your desk when the morning sun was just hitting the edge of your window. You felt fully present, locked onto a single target. Then you blinked. You looked up and the room was dark. The sun had set. Hours had evaporated into thin air, leaving you wondering where those moments actually went. Did those hours simply slip past while you were not paying attention? No. The reality is far more astounding. Your brain intentionally engineered that temporal void. To understand why this happens, we have to look at the energetic demands of your biological machinery. The human brain accounts for roughly 2% of your total body weight, yet it consumes more than 20% of your body's total energy budget. Within that biological engine, the prefrontal cortex, the region sitting directly behind your forehead, is by far the most energy-hungry consumer. This area is responsible for high-level executive functions. It runs your conscious inner narrator, manages self-criticism, plans for next week, checks social standing, and constantly measures the tick-tock passage of time. Imagine a massive metropolitan grid during an intense summer heat wave. To prevent the central power plant from collapsing under extreme demand, grid managers execute a deliberate strategy. They cut power to non-essential streetlights, decorative public fountains, and residential districts so that critical infrastructure, like emergency hospitals, can keep running at full capacity. Your brain executes the exact same maneuver when faced with intense cognitive demands. When you engage with a task that pushes your focus to its absolute upper limit, your neural circuits hit an energy ceiling. The brain cannot fuel high-intensity processing while simultaneously running your complex conscious self-awareness network. Something has to give. In 2004, neuroscientist Arne Dietrich published seminal research detailing this exact phenomenon, coining the term transient hypofrontality. Dietrich proved that under conditions of sustained cognitive focus or high physical exertion, the brain deliberately downregulates metabolic activity in specific regions of the prefrontal cortex. Transient means temporary. Hypo means reduced. Frontality refers to the prefrontal cortex. When you enter this state, the brain selectively dials down the dorsolateral prefrontal cortex. This specific structure is where your internal critic resides. It is the part of you that asks, "Am I doing this right?" Or "What if I fail?" Or "How much time do I have left before my next meeting?" When that region goes quiet, the inner voice dies down. The editor vanishes, leaving only the producer. Now, if you are finding this breakdown of transient hypofrontality fascinating and it is giving you a fresh perspective on how your own mind operates under deep focus, take a brief moment right now to leave a quick comment and subscribe to the channel. Sharing your perspective signals to the platform that deep, scientifically backed content truly matters, which helps us continue researching and unraveling the hidden biological mechanics behind human behavior, just like this. With the dorsolateral prefrontal cortex throttled back, another vital system shifts offline, your internal clock mechanism. How does your brain actually keep track of time when there is no clock in front of you? Your neural machinery uses an intricate network involving the striatum, the basal ganglia, and the insular cortex. These structures act like an internal metronome, firing rhythmic pulses of action potentials. Your conscious mind counts these pulses to estimate whether 30 seconds or 30 minutes have elapsed. When you are bored or disengaged, your prefrontal cortex monitors every single pulse of that metronome. Tick, tick, tick. Time feels painfully slow because your brain is actively counting every neural beat. Have you ever noticed how 10 minutes on a treadmill can feel like an eternity? That is because your prefrontal cortex is completely disengaged from deep focus, leaving it free to count every single pulse from your internal clock. When transient hypofrontality takes over, that counting mechanism is stripped of its resources. Dopamine floods the striatum during moments of intense task engagement. This biochemical surge accelerates the internal pulse rate while simultaneously blocking those pulses from reaching conscious awareness. The metronome is still beating, but the conscious auditor has stepped out of the room. Time disappears because your brain literally stops keeping score. Is time an objective reality flowing around us, or is it a customized mental simulation assembled entirely by neural energy allocation? It is a simulation. And when focus reaches its zenith, the simulation drops temporal tracking altogether to maximize raw processing power. This reveals a profound shift in how we ought to view our working lives. Before understanding this neuroscience, most people view losing track of time as a bizarre accident or an uncontrollable lapse in awareness. They believe time management is about constantly watching the clock, carefully measuring every hour, and fighting off distraction with sheer willpower. They treat time as an unyielding conveyor belt moving under their feet, constantly feeling guilty for not monitoring its speed. After understanding this biological process, you realize that time distortion is not a loss of control. It is the ultimate expression of control. Losing track of time is the clearest biological proof that your brain has entered its highest operational state, a state where performance surges, cognitive load lightens, and anxiety becomes physically impossible. In 2011, neuroscientist Judson Brewer and his research team at Yale University used functional magnetic resonance imaging to look directly inside the brains of individuals locked in states of deep experiential focus. Their brain scans revealed a dramatic, localized decrease in activity within the primary hubs of the default mode network, specifically the posterior cingulate cortex and the medial prefrontal cortex. The default mode network is your brain's baseline circuit. It fires up whenever you are not engaged in a specific goal-directed task. It is responsible for daydreaming, ruminating over past mistakes, projecting future anxieties, and maintaining your narrative sense of self. The default mode network is where doubt, regret, and stress live. Brewer discovered that when focus fully engages a task, the default mode network drops its energy consumption dramatically. The inner narrator is silenced. When your self-talk drops off, your self-consciousness drops off with it. And because your internal sense of time is intimately tied to your sense of self, to that continuous inner narrative of me experiencing this hour, the moment the self disappears, time vanishes alongside it. You cannot feel the weight of time passing if there is no internal narrator present to measure it. This is why peak athletic performances, masterwork artistic creations, and breakthrough scientific insights happen in these temporal voids. You do not feel tired, you do not feel anxious, you do not wonder if you are good enough. You are simply executing at the absolute frontier of your biological capacity. So, how do you deliberately trigger this neural state instead of waiting for it to happen by chance? Here are 3 precise, scientifically grounded strategies you can use to harness transient hypofrontality in your daily routine. First, lock in the 4% challenge skill window. Transient hypofrontality cannot occur if a task is too easy or impossibly difficult. If a task is too easy, your brain consumes very little energy. The prefrontal cortex stays fully powered. The default mode network remains active, and your mind wanders back to the clock. If a task is far too difficult, your brain senses threat, triggering the amygdala and unleashing cortisol, which traps you in a high anxiety state that fractures concentration. To hit the sweet spot, elevate the difficulty of your task so it sits roughly 4% beyond your current skill level. This creates just enough cognitive friction to demand total energy allocation, forcing the prefrontal cortex to pull power away from the temporal clock and self-monitoring circuits. Second, ruthlessly eliminate micro-interruption anchors. Every time your phone vibrates, a notification flashes on your monitor, or someone taps your shoulder, your brain suffers a rapid executive reset. The prefrontal cortex immediately rearms itself, bootloading the dorsolateral prefrontal cortex back to full power. When that happens, your brain turns the internal metronome back on. The default mode network reactivates, self-consciousness returns, and your sense of time instantly resets. A single notification does not just interrupt your work for 5 seconds, it violently pulls you out of transient hypofrontality, forcing your neural machinery to spend up to 20 minutes trying to re-establish that metabolic suppression. To preserve the time warp, clear your visual field of clocks and mute all incoming inputs for dedicated 60 to 90-minute blocks. Give your brain permission to stay offline. Third, implement a 30-second biological priming sequence. You cannot force transient hypofrontality through stress or sheer stubbornness, because stress elevates prefrontal hypervigilance. Instead, you must prime your nervous system to transition smoothly from high alert to calm, locked-in focus. Before starting a deep work session, execute a precise 30-second ritual. Sit upright, drop your shoulders, and perform 3 consecutive physiological sighs. 2 quick inhales through the nose, followed by 1 long, extended exhale through the mouth. This breathing pattern rapidly adjusts blood gas levels, triggering a release of acetylcholine from the nucleus basalis and norepinephrine from the locus coeruleus. This neurochemical signal acts as a biological green light, telling your brain that it is safe to downregulate executive self-monitoring and dive directly into immersive engagement. You are no longer a passive bystander watching hours slip away, nor are you a victim of an easily distracted mind struggling against the clock. You now understand that when time vanishes, it is not an error in your perception. It is your brain operating at its absolute maximum efficiency, shedding unnecessary neural overhead, silencing your inner critic, and redirecting every drop of biological energy toward what is right in front of you. What task made you lose track of time most recently? Like this video right now as a practical bookmark so you can return to this exact neural explanation whenever you catch yourself wondering where the hours went. Now that you understand how your prefrontal cortex silences time, you hold the biological key to unlocking deep focus whenever you choose. But mastering your brain's temporal clock is only the beginning of understanding the hidden biological forces that govern your everyday decisions, habits, and emotional drives. Subscribe right now so you do not miss the next deep revelation into human behavior that we are actively researching behind the scenes at this very moment.